chemistry class. Today we are going to discuss a topic from the first module, atomic structure and chemical bonding. Let's start with matter. Matter is defined as anything around us which can occupy space and has mass. This matter can exist in different physical states. It can either be in solid state like ice cubes, or in liquid state like water droplets, or in gaseous state like oxygen, carbon dioxide, etc. This matter can be broadly classified into two: pure substances and mixtures. Pure substances are those substances which have fixed composition. They contain only one type of component in them, whereas a mixture contains two or more substances present in it in any ratio, and these substances are called its components. Pure substances are again classified into two: elements and compounds. An element consists of only one type of particles, whereas different elements combine to form a compound. Mixtures are further classified as homogeneous mixtures and heterogeneous mixtures. In a homogeneous mixture, the components completely mix with each other and its composition is uniform throughout. For example, sugar solution and air are considered as homogeneous mixtures. In contrast to this, in heterogeneous mixtures, the composition is not uniform throughout and sometimes the different components can be observed. Mixtures of salt and sugar, grains and pulses, etc. are examples of heterogeneous mixtures. The elements are further classified as atoms and molecules. Now let's find out the differences between atoms and molecules. Atom, it can be considered as the smallest particle of an element, whereas molecules are considered as the smallest particle of a compound. Atoms were considered indivisible, which means that atoms cannot be further divided into simple or smaller substances, whereas molecules are considered as divisible. Some atoms like helium atom, neon atom, argon atom are all considered stable, whereas there are some other atoms, for example, atoms of oxygen, hydrogen, nitrogen, etc. are not stable. So we generally say atoms may or may not be stable, whereas molecules are always considered to be stable. Examples of atoms include helium atom, sodium atom, etc., whereas the examples of molecules include hydrogen molecule, oxygen molecule, etc. Initially, the atoms were considered indivisible, as we already said, but later on experiments proved that atom can be further divided into small or simple substances which are termed as subatomic particles. These subatomic particles are namely electron, proton and neutron. Protons are the positively charged subatomic particles with a charge of positive 1.602 into 10 to the power minus 19 coulomb and has a mass of 1.67 into 10 to the power minus 27 kilogram. Neutron is a chargeless particle in an atom with a charge of 0 coulomb and a mass of 1.67 into 10 to the power minus 27 kilogram. Finally, the electrons are the negatively charged subatomic particles in an atom with a charge of minus 1.602 into 10 to the power minus 19 coulomb and a mass of 9.11 into 10 to the power minus 31 kilogram. How these subatomic particles are arranged in an atom constitutes the atomic models. The very first atomic model was proposed by J.J. Thomson, and the atom model was named plum pudding model or the watermelon model. As the name suggests, the watermelon model of J.J. Thomson is very similar to the picture shown. Here, the red edible part of the watermelon can be compared to the positively charged particles in an atom, and the non edible black seeds in a watermelon can be compared with the electrons or the negatively charged particles in an atom. The next atom model was proposed by Rutherford, and Rutherford atom model was called planetary model of atom. It is very much similar to the way in which planets are arranged around the sun. As the sun constitutes the center of the solar system, in an atom the nucleus occupies a central position, and the subatomic particles, namely protons and neutrons, occupy the nucleus. Whereas the negatively charged subatomic particle, the electron, revolve around or moves around the nucleus in fixed circular path, similar to the planets moving or revolving around the sun. These circular path around the nucleus in which the electrons moves with very high speed is termed as orbits. The next atom model was proposed by Niels Bohr, and the Bohr atom model was based on the following postulates. In Bohr atom model, the electrons revolve around the nucleus in a fixed circular path termed as orbits or shells. These circular orbits will have a certain amount of fixed energy, and so these circular orbits are also termed as energy levels. The different energy levels are denoted by integers such as n is equal to 1, n is equal to 2, or n is equal to 3, and so on. These integers are called the quantum numbers, specifically the principal quantum numbers. The different energy levels or orbits are represented in two ways, such as 1, 2, 3, 4 as quantum numbers, or using alphabets such as capital K, L, M, and N shells. The first shell, that is the n is equal to 1 shell, lies close to the nucleus and is having the lowest energy. The energy of the orbits or the energy levels or the shells increases with increase in the distance from the nucleus. This is a diagrammatic representation of Bohr atom model. In the center we have the nucleus, the positively charged nucleus with the protons and neutrons. The very first shell in green color denotes the K shell with principal quantum number n is equal to 1. The second shell, the orange colored shell, is the L shell with principal quantum number n is equal to 2. The third shell in violet color is the M shell with principal quantum number which equals 3. And the fourth shell, that purple colored orbit, that is the N shell with principal quantum number n is equal to 4. There are certain merits and demerits for Bohr atom model. The merits of Bohr atom model includes the Bohr atom model could explain the stability of an atom very well. It could explain the atomic spectrum of hydrogen atom. It could also explain the emission and absorption of radiations by atom. The demerits of Bohr atom model includes it was not able to explain the Zeeman effect, that is the splitting of spectral lines in the presence of magnetic field. It could also not explain Stark effect, which is the splitting of spectral lines in the presence of electric field. With this we conclude the topic atom models. Thank you.